All right, this is Honors Algebra 2 Pre-Calc. We are jumping back into solving systems of equations. So we're now at the point where I'm going to give you some examples that you can do by any method of your choosing, which is more realistic to what's actually going to happen both on my exams and also moving forward in math. The point is to be able to solve it, and how you choose to do that is up to you. So a couple things. Number one, I am almost never going to advocate for graphing being your top choice unless your numbers are very large or very ugly decimals, which is not how I would classify 0.6 and 1.8. So if I look at this, I'll be honest, I do elimination almost all of the time as my gut choice anyway. But there are two good choices here. You could either do substitution, where you solve for this easy x, and that would be fine, right? Or you could do elimination. If you feel uncomfortable with the decimals, the honest, easy way around it is to make the second equation, just multiply the entire second equation by 10, which would get rid of the decimals because you probably don't love them. And then you could easily multiply the top by a -2 if you were trying to do elimination, because that would give you a 10 and a -10 for the coefficients of x. So I don't care which one you pick. If you did substitution, you should solve for this x, because that's by far the easiest. I'm not going to do that. I'm going to actually pick elimination because I think elimination is significantly easier. So it turns out that if you multiply the second equation by 5, you will actually get rid of both of these decimals. They'll be gone. Because a 5 times a 0.6 would give you a 3, and a 5 times a 1.8 gives you a 9. But if you don't see that, you could just multiply the whole bottom by 10, and then the top by a -2. So I'm going to multiply this by a -5, knowing that that's going to take care of the decimals and let me eliminate my x's. So when I multiply by -5, I'm going to get a -5x minus 3y equals -9. And my top is going to be a 5x minus 3y equals 8. So the x's are going to eliminate, which is the whole point. Notice that the y's don't, and that's a common misconception. The y's are not going to eliminate. So you're going to end up with a -6y equals -1. So you're going to get a y equals 1/6, which I know is not super fun and awesome, but that's where we are, right? Once you know that your y is 1/6, there's a couple different options that you can use to try and, clean this up. I'm guessing most of you are going to opt to plug into the one that does not have a decimal. So you're probably going to do 5x minus 3 times this 1/6 equals 8. So you're going to get 5x minus a 0.5 is 8. So you're going to get 5x is an 8.5, which means x is a 1.7, because 85 divided by 5 is 17, right? You would have gotten the same thing in the other direction. I get that this is not super fun. I'm going to leave the 1/6 as a fraction because this is a repeating decimal. So if you did write it as a decimal, it would be a 0.16 repeating. The 6 is repeating, not the 1. So it's actually better to leave that as a fraction. If you chose to write this as a fraction, it would be 17/10. I would suggest that you avoid the 1 and 7/10 notation. Avoid mixed numbers. Okay, so avoid mixed numbers. And again, I get that that's the first one we've seen where it's not nice, happy values. The other option is if you see these decimals and your first thought is, no way, I'm not going to do that, you could easily graph this one. Keep in mind that if you graph it, you're going to have to recognize that this is actually a repeating number. The 1.7 is not. It's just a 1.7. So, all right, moving on to P6. So you're going to give P6 a try. Again, pick a method you want. For me personally, again, I really like elimination, but also here it's the most logical choice. There is no easy variable to solve for to do substitution, and I'm never going to pick graphing as my first choice unless I have incredibly large numbers or very ugly decimals. So I'm going to pick elimination. I'm going to choose to eliminate the x. What that means is that I need to get a common multiple of 10, right? Because between 5 and 2, the common multiple is 10. So I'm going to multiply the top by a -2, and I'm going to multiply the bottom by a +5, because that'll give me a 10 and a -10. So I'm going to get a 10x plus 15y. Oh, my bad, guys. Sorry, it's that silly, pesky button that gets in my way sometimes. 15y equals 25. And on the top, I'm going to get a -10x minus 8y equals -4. When I add straight down, I get a 7y is 21, so my y is 3. Once I know y, I'm going to pick either equation. In this case, I'm going to go ahead and pick the 2x plus 3 times 3 equals 20, or equals 5, my bad. So make sure you use the original, right? So I get 2x plus 9 equals 5. 2x is negative 4. X is a negative 2. Cool. So, oh, and I did forget to classify the last system. This is consistent independent because there is a solution, right? The solution is the negative 2 comma 3. And if I go back a slide, my bad, I was told to classify the system. This is consistent independent. Cool. All right, moving on. Cool, so we're going to solve a system by a method of our choosing. So this one's kind of ugly, right? There's a lot going on here. So I'm going to suggest a couple things. Number one, I'm going to suggest that I hate fractions. So one, I hate fractions. Not as much as I hate ugly decimals, but I think we all hate fractions. So if I just start by saying, hey, you know what, I'm going to multiply this thing by 2, I'm going to end up getting a 14y minus an x equals a 4. Hey, no more fractions, right? And then I'm going to go one step further and put this in the order that we're used to seeing it. You don't really have to, but it's just more comfortable. Okay. The second thing I notice, right, is that this is out of order. So I'm going to fix this by subtracting the x over, right? And then negative 2y equals 4. Cool. So now I think, all right, you know what? This is an easy thing to eliminate. I'll just pick this. Why don't I multiply my second equation by a negative 1? Now, if you'd spotted this early on, you could have multiplied by a negative 2 instead of a 2 up here, right? So the second thing I noticed was that equation 2 is in the wrong order, and I fixed it. So now it looks like what I've got is a negative x plus 14y equals 4. And a positive x plus a 2y equals negative 4. When I add straight down, I seem to get 0 plus 16y equals 0, so it looks like y is 0. Well, if y is 0, then I can pick either equation to solve for x. So I'm just going to go back to the negative 2y equals x plus 4, 0 equals x plus 4, so negative 4 is my x. So that's my solution, right? Both of those guys together, either written like that or written as negative 4 comma 0, and my classification is consistent independent, right? Because consistent means you have a solution, independent means that the two curves are not the same. All right, P7 is kind of ugly, no lie. Just a heads up, there are 2 x's here. So you're going to have to do a little bit of combining some like terms before you do other stuff. Well, so you have a couple options. So that's ugly, but I do want to point out that this is a perfect system for substitution. Right? This is like, hey, please go ahead and substitute that x with other stuff, right? So if I were you, I'd probably clean up the top, right? So I would say, you know what, equation 1, I'm going to fix the fraction. I'm going to say, you know what, I really hate this. Let's just multiply this whole thing by 2. So that's going to give me an x plus 3 equals a 2x plus 8y, right? And then I'm probably just going to say, hey, everywhere I see an x, it's actually a 5y. So 5y plus 3 equals 2 times 5y, which would be 10y plus 8y, right? If I put all my y's on the same side, it seems to me that I get a 3 equals 18y, right? Minus 5y, which would be 13y. So I get y is 3 over 13, which I get is no fun at all, right? But conveniently, I have a nice, easy formula that's already solved for x. So it's going to be 5 times this 3 over 13. I'm going to get that my x is 15/13. And sure, that's no fun, but it's an answer, right? So these guys are my solution. And when I classify this, this is consistent, independent. And you might think, hey, with all these ugly fractions and ugly answers, I would rather just plug in to the calculator, but it's not going to be an easy thing to solve any of these in a calculator either, right? It's not like this is going to be super duper awesome and fun in a calculator.